Okay, this video is for the thermochemistry problems number 2A and 2B. So it says sketch the cooling curve when 35 grams of water vapor, that's just maybe you've heard of it as steam, at 135 degrees Celsius is cooled to liquid water at 25 degrees Celsius. Alright, so I know some people would maybe draw this starting up and going down, but I just like to draw in the same way every time and just kind of work backwards. So it's an up, over, up, over, up. Alright, remember that you have a solid, a liquid, and a gas here. Alright, this point right here is 100 degrees Celsius. So is this point right here. And then down here is where water melts or freezes, 0 degrees Celsius. So this is also 0 degrees Celsius. Okay? Now, anyway, we're starting in this case up here at 135. So we're starting, I'm just going to mark it up here. So that's like 135 degrees Celsius. And then what's going to happen is you're going to have to take some energy, heat energy out of the water, some thermal energy out of the water until it reaches 100. Okay, and it will be steam here. Okay, the water vapor, you got to take it out, and then you'll have to change it to liquid. It'll change to liquid water, and then it's got to cool some more, and we got to cool it down to 25 degrees Celsius right here. So this is where we're stopping the problem right there. All right. So I think it's important to number the steps. We have step 1 to go from this point to this point right here. We have step 2 is to go from here to here. That's to condense the water. And then the third step is to cool the water down. So let's start with step number 1. All right, so step number 1, the graph is slanted. Wherever the graph is slanted, all these problems will be kind of the same. You're going to use a Q equals MC delta T because wherever the temperature is changing, you're going to use the Q equals MC delta T. So then you plug in Q equals the mass, okay, 34.5 grams of water. Now, the specific heat of water vapor, we just use the same value as we did for ice. It's different than liquid water, so it's going to be 2.9 joules per gram degrees Celsius. So we're going to multiply that times 2.09 joules per gram degrees Celsius, and we're going to multiply that times the temperature change. Now the temperature change is basically 100 minus 135. So because we're just going from this point to this point, but it's always final minus the initial. So you end up getting a negative number because you're taking 100 minus 135. All the negative number means is that the energy, the thermal energy, has to go out of the steam. The negative means it's just going out. So anyway, you go Q equals, so then you take 34.5 times 2.09 times a negative 35, and that equals 2,523 or 24, I guess if you round it, joules, but we're going to change it to kilojoules, so we're just going to move the decimal 3 spots. So that's going to equal 2.52 kilojoules. All right? Okay, question or step number 2. Okay, number 2, we have to condense the water. Whenever you have a gas and you're going to a liquid, that's called condensation. All right, so we're going to use the heat of condensation. So that sometimes is like delta H COND, and that number is equal to a negative 40.7 kilojoules per mole. Now that number would be given to you on a test, so you don't have to memorize it, but that's called the heat of condensation. All right, so step number 2, we have a Q equals MC delta, no, not that. We're not going to use that because it's a flat spot. Okay, so we're going to use the mass, so 34.5 grams of water vapor, and we're going to change that to moles using the molar mass. So 1 mole of water, that's going to be equal to 18 grams of water. And then we got to use the heat of condensation, which says for every 1 mole we want to change from a gas to a liquid, that mole has to lose 40.7 kilojoules of energy. All right, so we'll take 34.5 times 40.7 divided by 18, and that number ends up being around a negative 78.0 kilojoules. All right, and I forgot down here on number 1, these values should be negative, by the way. All right, now that's part 2 is negative 78 kilojoules. Okay, so now part 3, all right, so we did part 1, part 2. I don't know where my part 3 went, but part 3 is going from, we have liquid water at 100 to liquid water at 25. So that's the third step. All right, so the graph is slanted right there. So we're going to go Q equals MC delta T. That's what we're going to do there. So Q will equal the mass of my water, which will be 34.5 grams, times the specific heat of water. Remember, liquid water is 4.18 joules per gram degrees Celsius, times the temperature change of the liquid water. Well, it's going from 100 to 25, so it would be 25, let's see here, 25 minus 100, so that's going to be a negative 75 degrees Celsius. So negative 75 degrees Celsius. So when I do the math for that, I get 34.5 times 4.18 times a negative 75. So I get 108.15 joules, but then I want to move the decimal 1, 2, 3 spots. So that's going to equal roughly about 10 let's see here, what did I do here? That should equal like 10.8 kilojoules, I believe. 10.8 kilojoules. All right, now this number should be negative when you do that there. All right? All right, so now what you're going to do then is you have to add all 3 steps together. So step number 1 is a negative 2.52 kilojoules. Step number 2 is 78.0 kilojoules. And step 3 is 10.8 kilojoules. And if you add those 3 together, that will be your final answer for that. So let's see, what does that equal when you add them together? So let's see here. So 2.52 negative plus 78 plus 10.8. So I get 91.32 after I add those all together. So 91.32 kilojoules, but I'm just going to round it to 3 significant digits. So that ends up being 91.3 kilojoules. And the negative number just means that that's how much energy has to go out in order to change it from gas to a liquid. All right, that's it on that problem. So after you get done with this, looking at 2A and 2B, then you should try to do 2C yourself and then check your answer using the answer key to see if you have the right answer.